A very good day for all audience. My name is Ku Chun Chen from Soil Instrument, student from UTHM. Now I'm working at Soil Instrument and the project is based at the Kelantan for the Nenggiri Hydroelectric project. Now I would like to present my paper with a title of A Concise Introduction to the Development of RCC Mixed Design for the Nenggiri Hydroelectric project. First of all, I would like to introduce about the RCC. It is same as the soil embankment. It involves the steps of 3mm layer were deposited by the dump truck, then leveled by scraper, and lastly consolidated by the passes of a vibratory roller. So why do we choose the RCC? Because of its advantages, which can be environmentally friendly and also cost effective. This is because of less cement is utilized for making the mixed design for the construction of RCC. That's why it could be effective for achieving the SDG, which is the hot topic now for all global around the world. RCC should be designed based on the feasibility study, which have been made for the Nenggiri hydroelectric main dam based on the situation, which is the site, is it applicable or not for construction of RCC based on the economic and also based on others factor. Now I would like to present the two factor which is mostly to be concerned, which is first one, availability of the large amount of the limestone near the earth surface and also have a good foundation aggregate near the dam site. That's why it can be applicable for using these natural resources for construction for RCC construction by using this aggregate which is available on the site which or near to the site, and also this can be benefit for the people, like it can reduce the risk of flooding and also can produce the clean and raw water for the cultivation. The purpose for me for doing this research because of this a few of challenges. First one, because of the mixed production play an important role in RCC dams construction, which is determining the all properties of RCC, which is start from the mixed design. That's why mixed design should be made properly based on the requirement. That's why various mixed design will be developed and identify all the properties based on the spec, and also the prospect of obtaining the suitable material could be challenging based on the site. That's why all the materials should be evaluated and also testing, and then based on the properties which is made from these natural resources, we can do some exercise of adjusting the mix proportion to achieve a desirable final product. And also, last but not least, the trial placement should be concerned after all the mixed design have been developed to ensure the suitability and efficacy of the design mix prior to proper placement. The objective for this research is to evaluate the RCC material mix design and also to develop a RCC mix design protocol. Now we are moving to the methodology. So first of all, we have to start from sampling of RCC material to evaluate the RCC material, which are the aggregate, cement, fly ash, and mortar based on the spec. Firstly, for the first stage of RCC mix design, we should like evaluate the suitability of using the mix design, like the molding the RCC cylinder for the testing of direct tensile strength and also the compressive strength. And because of RCC is a zero slump concrete, that's why we should use the technology of measuring the slump for the zero slump concrete like BB time to determine the consistency and also can determine the density based on the test method. And also setting time is most concerning because this RCC is compacted layer by layer. That's why the setting time should be identified for the site construction. And then the alkali aggregate potential reaction also is the things that we should concern to determine the durability of the concrete. So after we have finished the first stage of RCC mix design, we will select one or more mix design that should be further studied. So in second stage, we will do the detailed study more on thermal properties, strength properties, and lift joint properties determination. Lastly, the selected mix design also should be trial placement before the proper placement, which could be inspect and evaluate based on the site production for the trial embankment to evaluate the permeability and also the in situ strength based on the site production. So currently we are doing the progress on the evaluation of the material like aggregate. So the process for now, we have identified the water absorption, and also the SSD for the aggregate group 1, group 2, and group 3. And we also have inspected the production of the aggregate like G1, G2 for the particle shape to inspect the consistency of the production of the aggregate and also should be compliant to the requirement. So this one is the continue for the G2 result for the particle sheet. Then after we have evaluated the material, we are going to have a preliminary dry mix based on the aggregate, which is the compact aggregate that can be utilized for making the dry mix, which is the graded one. As you can see from here, here are the preliminary mix design from different mix design. What you can see from the table here, we got the VB time, the result for the VB time, density, the compressive strength, then direct tensile strength, and also the setting time. So as a result, from the preliminary mix design, got 5 mix design are selected for the next stage, which is the first stage of the mix design for the further study as highlighted in orange color. That's all for me. Thank you.